Hi guys, and welcome to another quick physics minute. Today we're going to talk about the ideas of torque. Torque is just a rotating force, but it can be seen two ways. One is the idea that we just define it as simply a rotating force. So in this picture that we have drawn here, we're trying to show that we have something like this, a wrench, and that the wrench can go ahead and provide a rotating torque to turn something. Now, we find that torque is calculated by R times F times sine of the angle. R is the radius, or the point from the central point to where that force is applied. F is the force, and sine of theta is the angle between the radius and the force applied. Basically, what we're defining that as is something like this. That would indeed be R for pushing that way, and the angle between them, we call that the theta. Now, notice this goes ahead and turns to 1, or just basically the radius times the force if we're just looking at stuff that's applied perpendicularly. We get maximum forces when we push perpendicular to how this thing is set up. If I do something like this, push it this way, I'm not going to get anything. If I push something like this, it's not going to work nearly as well. Another way to look at it is, this is a big multiple choice type of question, is if we look at a sign, that's supposed to be a sign hanging like this, okay? And if that sign has a bar attached to a wall and there's two ropes that are hanging like this. We could do this as a tension problem, or we could do this as a torque problem. One way to look at that is, if we're saying if the sign is basically fixed to here, we're saying this is completely horizontal. That means from here, this thing would try to be spinning out this way, right? So what we have to think about is, if this is a rigid bar fixed to this sign here, this thing is trying to go ahead and rotate, there's attached to a cable there. That means we have force gravity going this way, and we have a tension going that way to provide that torque. In this case, if it's not spinning, that means those two torques are equal. Now, how can that be? Well, the torque here is, or basically the tension force is that way. This vertical component of that would have to be equal to that. If you're looking at this and saying to yourself, this kind of looks like old force stuff, that's because it is. We're just saying, okay, well, that is trying to spin one way or the other way. Same thing with the seesaw. If I have something here, it's not going to spin if those two torques are equal. If I go ahead and I look at it like this, I could go ahead and have a larger force here, but if I have a shorter distance, the same thing still applies. The other way in which torque can be analyzed is by its fundamental definition, is that torque is not just a rotating force, the idea that forces make things accelerate. That means that it provides angular acceleration. We define that as the sum of the torques, all of them put together, is equal to the rotation inertia multiplied by the angular acceleration. That's basically fancy stuff to say unbalanced torques make things accelerate. If we look at a wheel, and we see that we have a wheel like this. If I make this thing start spinning, I apply a torque to it. If I make this thing stop, I also apply a torque to it. The way in which it accelerates when I apply that torque is dependent on its mass and where that thing is located. So an easy way to see this thing is if we say that we have a wheel and it spins faster or slower, and we say about the force being applied that way, or we talk about brakes being applied to a wheel, that provides torque to it to cause the thing to spin slower, or we could talk about it spinning faster, both of which apply ideas of torque. Thanks, and have a great day.